Who are our panel members?
So our panel members here, Nathan Palmer, Sandy Aronson, and Shawn Murphy. Absolutely.
Yep.
And I don't know who is up first. And so who will be speaking first?
Sandy? Well, I see Sandy's things first. So I just want to, I'm going to be brutal because I want this to be an actual discussion. So you have three amazing speakers, and I think as interesting as what they have to say individually is what they'll have to say to each other. So here's where I get brutal. I'm going to ask you all three, as we've discussed before, to be brief. Introduce yourselves. Go through whatever slides you need to go through rapidly. If I see you taking too long, I'll be nasty, with love. And then we'll engage you in a conversation with each other, which may either happen organically or I will prompt. And then I will work with the audience to have questions beyond that. Fair game? All right, so I see Sandy. Why don't you take it?
So I'm Sandy Aronson. I direct IT and AI solutions for Mass General Brigham Personalized Medicine. I've been in this role for more or less 22 years. There's been a lot changed. There's one thing that's remained consistent, which is never agree to go in a slot on an agenda after Zach speaks. So I have just a brief disclosure of things that I'm going to talk about today. I am a founder and equity holder in a company called AI with Care that does work in this space. So I just have 3 slides, 3 different figures, and just to set up the first 2, we are running a clinical trial in the heart failure space where we have to recruit a lot of patients. The way the trial works is we have our study staff go through medical records, look for patients who may qualify. They need to read notes, an average of 125 notes per patient, to assess 13 inclusion-exclusion criteria for the trial. What we decided to do was look at whether we could use a large language model to pre-screen those notes before the study staff does their screening, to try to increase the number of the number of patients they would find for the trial by excluding the negative ones. When we did this, we found good concordance with study staff. But we looked at the places where there was not concordance. And the gold standard for this is a clinician who ultimately reviews each patient before they're enrolled. So we looked at 6 patients where they were unconcordant. The large language model tended to do better. That led Ozzy Unlu, a cardiologist, to go look at more than 1,800 patients that had previously been assessed, to develop his own assessment. And we compared large language models to study staff compared to the gold standard clinician. It beat them in every category of performance that we looked at. Sensitivity was not statistically significant. Everything else was statistically significant. So then what we did is a prospective randomized trial to look at what would happen if we compared study staff augmented by AI capabilities with study staff unaugmented with AI capabilities. Enrollment went up 84% for the staff that were augmented compared with the staff that were not augmented. Last slide, totally separate thing. This is a study that is a word of caution that is in the same area, that in a different dimension of what Zach was talking about, of looking at drift and non-determinism. This is literature review in genetics, but it doesn't matter. What this is these are runs of the exact same data set over time on different large language models, but also on the same large language model on different days. The dotted line is the one change that was known to have happened in the environment. So everything else, temperature set to 0, fingerprints are consistent, and what you see is different performance. So in addition to the changes in medicine, the changes in data, there's also concern about the models themselves changing in ways that at least we were not able to detect. In addition to the error bars at the end, that's non-determinism. That's the same data set being run again and again on the same day and producing different results. So these are things that are also like really important to keep in mind as we try to develop the hazard profile and protect against it from these models.
Thank you, Sandy. Someone could give slides? You want to use the Windows machine?
Kind of.
All right.
Thank you very much. So while they're setting up, just want to ground us in. So the question is going to be, how are we going to take this fantastic new technology that we have in large language models and enhance what we do for I2B2, which essentially is supporting finding patients for clinical trials, like Sandy's discussed, and the nuances of being able to use I2B2 to find them across the country in ways that, you know, were envisioned back when we created I2B2 and put together this suite of plugins, I guess it was at the time, to make sure that we could accomplish the goal across the country of, in a kind of diffused fashion. So we don't do a central kind of database. We allow people to operate in their own hospitals according to their own principles, but to find patients for clinical research and put the data together in ways that are necessary to prove whether our treatments are actually working. So in this way, we kind of put together this way that we could create profiles of patients through many different kinds of data and put it together in a central location, building what we really call the digital twin of a patient in the database from all these different kinds of data, ultimately being able to study the patient in these enclave databases. And adding these capabilities of large language models can actually diffuse itself across I2B2 in ways that perhaps only people who are really intensely familiar, by the way, with I2B2 will understand. So a lot of what happens when you ask about a set of patients is, what do you call all the different pieces of data that you want to determine a patient actually has? And we call that an ontology. And so we have millions of names of different kinds of things that you can have in your patient. And it becomes almost unusable sometimes. Fortunately, we have Michelle Morris, who is able to really allow us to do this from Pittsburgh by really managing these millions of items. But the fact is, searching through them can be tough. So we look at this ability to chat with an ontology panel and find precise terms for things like diabetes is one big win. Do a smart lookup for a study. So actually be able to put the study text into the I2B2 client and say, what terms should I be able to use for cluster 5, for example, that we have in Recover for a JAMA panel, and it can actually come up with the terms. We have a lot of trouble documenting what to do in I2B2. It's a very complicated tool, and so being able to guide things like administrative tasks and set up new projects modeled after the demo project, for example, for an administrator who is struggling, is something we can do with large language models. Formulating queries and browsing tables, coupling with the ontology browser such that we can do things like run a query that returns a number of patients prescribed antihypertensive after the first reliable indicator of hypertension. That would be a tough query to set up in I2B2, and being able to do that using the large language model, it could show us what we get. Something like digesting study documents and making queries. So again, we can take things like clinicaltrials.gov-based studies and pull out the criteria and formulate an I2B2 query that makes sense to answer the questions of participant inclusion. Chatting with the query browser, adding criteria, for example, to exclude prisoners. How would you do that? And it can answer, there are no terms in the ontology to designate a patient as a prisoner. And then finally, being able to explain formulated queries, such as your query formulated a patient who is of female gender and is one of many has one of many circulatory system diseases. Now, I'm going to differentiate that you don't need notes. So I2B2 classically has been used to chat, right? And you have this ability to manage without patient notes in de-identified data. And when you get into notes, you're going to get into problems with how are you going to manage the notes in I2B2? And how is that going to be accepted so that we can put in the right processes to manage the notes? And so I divided this kind of into working without notes, so we can actually take advantage of large language models even if we don't have notes, right? And how that can happen with I2B2, chatting with the ontology panel, and using something we call the new AI cell. If we add notes to I2B2, and we're going to look at that in a workshop, by the way, that we're going to have tomorrow from 10 to 12. But if we do this in ways that are prescribed, now we can do new things. We can make the notes into embedding vectors, right, that describes the semantics of what the note means, and search that. So pre-populating our visit table with these embeddings and being able to vectorize our question and be able to search what questions directly in the notes, very much like Sandy described. And then we can use something called retriever augmented generation on subsets of notes to really search for participation criteria exactly as Sandy described. We can formulate NLP queries. So using what I'll call old-fashioned NLP works much faster than some of these embedding methods. Over 400 million notes, for example, that we have in Mass General Brigham. But they're very hard to formulate sometimes. And so being able to have that large language model help you find evidence of a patient being a current prisoner and then telling you, use the text query box and put prison percent as the value you're querying for is important. Thanks, Zach. And then finally, there's whole workflows of large language models that we can put in. So creating silver standards for computed phenotypes, and being able to do this in an automated fashion, creating new structured data for patient representations such that we can actually pull out from the notes melanoma staging and then query it in a high performance fashion, and then contribution to single patient electronic profiles. All of this through this new AI cell being created that can then accomplish creation and organization of data for clinical trials, ultimately being able to, within I2B2 itself, create silver standards to actually be able to get to what we really need, which is quality data to find patients for clinical trials. Because with the problem we've been faced by using real-world data, it's not collected for research. And its quality is not of research quality. But by using large language models in the fashion that we just have been looking at, we can actually make a new face on I2B2 such that it can actually answer our questions make sure the quality of the patient is exactly what we're looking for and their features, and find patients much more reliably and predictably for clinical trials and conduct those studies, clinical trials, in our data that we have in ITB2.
Good morning, everyone. Thank you, Zach and Diane, for inviting me to the panel today. My name is Nathan Palmer. I run a team of scientists and engineers at Harvard Medical School that provide a variety of support functions and consulting services to both educators and researchers. And through that experience, over the last more or less year, we've spent a bunch of time helping people who have a lot of good ideas in the AI space figure out how to actually implement them. And what that experience has shown me is that folks have a lot of pretty basic questions about where the rubber meets the road that they're frankly afraid to ask for the sake of looking dumb. So what I brought here today is a set of slides, rather than talking at you, I think are supportive of a discussion that we'll have with the panel about how to get started with some of this stuff, what it can actually do, what it can't do. So this is just going to be food for thought. I'm not going to go into any real depth on these slides. This is catalyzed thought amongst the audience for questions, thought amongst the panel members, things we might dive into a little bit. Along the lines of what Shawn was alluding to, we've done a lot of work with actually automatically generating SQL statements. So this is a party trick that Zach was impressed by when I talked to him about, but it's actually a party trick that he told me about first, which I repeated back to him. So basically the idea is take a standard looking data dictionary, and this isn't for an I2B2. Unlike all of you folks, I don't actually have an I2B2 instance at my disposal. This is for a large insurance claims database that we bought from Inovalon. The data dictionary, if you print it out, is something like 60, 70 pages or something like that. Basically, we took the PDF and asked ChatGPT to generate a markdown version of that, and then wrapped a prompt around that, right? So it's fairly long context here, but that whole data dictionary essentially is creating context for the LLM to start thinking about how you actually formulate a query. So this example I have up here just says, you know, I'm about to tell you what a data dictionary looks like. I'm not going to show you the whole dictionary. So imagine between the end dictionary tag there, we've got, you know, the 70-page document that describes, again, this looks a lot like an I2B2 sort of star schema database with a bunch of dimension tables, lookup values and things like that. And then it gives it a bunch of criteria. You know, I want you to join tables in such and such a way, create indexes as you go, create comments. So the italicized text is the response to the LLM here. You can give it simple English language statements. I want to calculate the average cost of hip replacement in patients with at least 2 diagnoses related to type 2 diabetes. And I think this is sort of underneath the hood, some of the things that go on in the types of work that Shawn was describing as well. And then it comes back and says, okay, these are the assumptions I'm making, these are the codes we're going to use, and then generates coherent SQL that actually works. This isn't the entire example here, but you know, you get the idea. And we actually ran this, and it actually does what you're asking it to. I think actually maybe a little bit more interesting probably for this audience is the notion of using LLMs to help you design a study rather than writing the SQL, which we all know at this point, there's plenty of documentation saying that these things are very good at writing code. Maybe it's a little bit more surprising they can use a database schema as a reference point and still generate coherent code. But one level up from that, start chatting with it to help you design the scientific experiment that you want to do inside of your data. So here, you know, I cooked up this simple example. I have a large I2B2 database, and I would like to study risk factors associated with autism. And it comes back and it starts talking to you about, okay, what are the codes you're going to use? What does a case look like? You might consider restricting cases to where you've got multiple diagnoses or specialist evaluations, define your control group, select candidate risk factors. So it actually turns out that it actually does know quite a bit about I2B2, and this isn't limited to just the big fancy GPT models. I've run some of the more modest size, 70 billion parameter llama models, and it also knows quite a bit about I2B2 and study design. And then finally, I wanted to chat with you guys a little bit, if you're interested, where do I run these models? Like, how do I get started? What are the use cases for different size models? So we can dive into that. We can think about what you can do at the edge, what you can do on a laptop or a desktop, workstation class machine. What do you need to do in your data center? And I think this is particularly relevant to what we're talking about here, where there are serious privacy concerns with some of the data. And then if you need to lean on some of the biggest models, how do you do that in the cloud with perhaps private deployments of some of these fancier models? And then if you're interested, I can talk to you about what our experience has been using various local deployment technologies as well. And this is just another simple example of what it looks like to use some of these technologies running on your own local infrastructure. So with that, I will turn it back over to Zach.
Thank you very much. Take a seat. So, a lot of food for thought here. I'm going to start by just doing a boring thing, which is I'm going to ask each of you, Nathan Cross, I'd like to know to what extent have you, in fact, been bothered by determinism of these models? I don't know how non-deterministic it is for the SQL, for example. And if you have to, sorry, and if you have been bothered by the non-determinism, what do you do about it?
That is the key question. In this context, I'll say I've been bothered quite a bit by the non-determinism. As Sandy was alluding to before, there are a variety of parameters you can tweak on these things to try to get it to behave as deterministically as possible. But at the end of the
zero
day,
temperature doesn't do it.
it doesn't do it. It doesn't do it. I will say that even the best models in terms of the SQL query generation don't always produce the same output. And they don't produce the same output, not in bug-prone ways, but in idiosyncratic coding style ways, which was odd, I found. I think one of the most concerning cases of non-determinism I've seen is in a paper that was published by some of our colleagues at MIT and Microsoft Research, where they were looking at unfaithful explanations for the responses. Yeah. So they gave a simple example where they prompted the model to say, there are two people applying for a position as a nurse. And they were intentionally vague about the qualifications of both people, but one was labeled as a young woman and the other was a middle-aged man. They gave, again, vague things like one's intelligent and highly motivated, the other one's a caring personality. And the model comes back and says, they say, who should be qualified best for the job? And the model comes back and chooses the female. And they say, why did you choose that? And it picks out the vague explanation in the prompt saying, oh, well, she's caring and thoughtful. They then fed it the counterfactual, left all the details the same, but flipped the gender on the two people. And again, it picks the female and picks out the details related to the female, which were the ones associated with the male before, as a justification for the choice. I think if we're going to be relying on these technologies to help us make decisions about things like prioritizing patients for care, then we need to be very vigilant about the ways in which it's trying to perhaps hide its unsavory biases. And that's just one simple example of the sort of non-determinism that.
Well, that's a very good point. And by the way, what's fascinating, these models are just as good as human beings at giving, after the fact, reasons why we made a decision that are totally unconnected to the real reasons we did decisions, whether we were aware of it or not. Shawn, so you have a real issue there too, right?
Yes. So Non-determinism is exactly why I kind of divided this panel, or the slides there into with notes and without notes. So without notes, we can use large language models to help us create the same structured queries that we've been using all along, right? It can help us do it better, more efficiently, but ultimately we can see the query, we can see the terminology being used, and we know exactly what it's asking for. When you use notes, you introduce a little bit of this indeterminism, which might have an impact or might not. If you're looking for a group of patients for a clinical study, and you're going to interview those patients later anyway to determine if they're really going to be okay for your clinical trial, you just need to get pretty close and know pretty closely the number of patients that you're going to be interviewing, right? So that's perhaps an appropriate use of large language models. An inappropriate use of large language models would be something where you're trying to determine if a patient, if they have certain social characteristics, should qualify for treatment, right? Because in those cases, you're going to get a lot of non-determinism in your answer. And in fact, the group of patients that you end up with is going to be quite unreliable, I will call it. So I think that using old-fashioned computer science to overlay a certain amount of determinism on an answer that can compensate then and be used appropriately where non-determinism would really potentially lead things astray.
That's a very good point. And someone in my own lab was trying to get, I think this was the wrong thing to do, was trying to get large language models to execute guidelines. And that's probably where a straight logical inference would be right, because it would give a different interpretation of the guideline at every shot, and so it became very unpredictable. So I'd like to go to Sandy. Sandy, you introduced us to not only the non-determinism, but again, reinforced that for something as concrete as interpretation of a variant, these things, models change, especially the larger ones, in ways that we don't know, because we don't see the code base or the weights. You have a business now. How are you going to reassure your clients that because your LLM's having a bad day, because you didn't give it enough coffee, it's going to do a terrible job compared to yesterday on selecting patients?
Yeah, so I think that it's useful to separate the notion of non-determinism, which is for this purpose defined as you repeatedly give a model the same data on the same day, same point in time, and it gives you back different results, from drift, where either the model is changing, the data is changing, the environment is changing over time, and you get different performance, different results. In some ways, I think that the non-determinism is easier to deal with because you can characterize non-determinism in advance. If you create a labeled data set, you can repeatedly run that labeled data set and you can test how non-deterministic the model is. And what we found is that it does depend on how difficult the task is for the LLM. In our hands, at least, the clinical trial evaluation, inclusion, exclusion, and valuation, was the models perform better on that than on genetic literature assessment. And as a result, the non-determinism that you see is less, statistically less. So in my view, this all comes down to you need to do hazard analysis. You need to look at what are the hazards of a correct and incorrect answer, what is the risk that non-determinism will give you incorrect answers, and is your process robust from a hazard management perspective relative to that risk. drift, I just say, there you need to be monitoring over time because you can't predict drift the way that you can measure non-determinism.
I think that's a very thoughtful answer, and I'll just corroborate it the following way. In that archive paper that I wrote, I had, in my mind, afterwards, I labeled the pairs as to easy decisions versus hard decisions. An easy decision is you need to ask to see in the next day a healthy patient and a not healthy patient. And for me, it was easy to decide to see the sick patient. And sure enough, the models also were more consistent, more concordant with me, and more self-consistent, going to your point. But I have to say, I'm a little worried because these models are trained in ways that we don't fully understand, or that we barely understand, to be more accurate. And I don't know, in fact, if a benchmark data set will actually reveal the same non-determinism or variance if there's something different about the other decisions it makes.
Yeah, I think that you could consider that an element of drift. Like that you need to, and you do need to make sure that I think that this hazard analysis is incredibly important. And you need to make sure that you're characterizing like all of the risks, including the risks of what you have and haven't assessed. And make sure that what you're deploying the model for is safe relative to its known and unknown performance characteristics.
We could have a longer discussion about it, but this is actually part of the problem that the FDA is having in evaluating the generative models as opposed to the previous generation of AI models where it's a narrow task defined, typically it's a discrete or a prediction task. And here, because these are general purpose models, within the same domain, task domain, you can actually have different distributions of data. So it's not so much data set shift, because the distribution of the overall model is the same, but they just haven't exercised it or tested it in a part of the distribution.
So Zach, if I could.
Please,
I
this is what I
realize
want.
that I sidestepped the second half of your question, which is, what do we do about it?
Yeah, please.
And I think it's important to think about two separate topics here. One, the models are non-deterministic by nature, but I think often we look at the results when we're chatting with ChatGPT and see inconsistency. And inconsistency is not necessarily always the result of the non-determinism of the model. It can be the fact that OpenAI just loaded a new checkpoint underneath you, and it's not giving you the same answers today that it did yesterday because you're fundamentally working with a model that's been trained on other data. So the question about what to do about it, there's no one-size-fits-all solution. I think it depends on the task. When we're looking at text generation, I think you sort of embrace the non-determinism. I think other times we use these models for things that more traditional statistical machine learning approaches would produce a deterministic output. Think of something like document classification, right? If you just give a ChatGPT a prompt and say, here's a document, does it describe, one example we worked on with someone in healthcare policy, looking at classifying mergers and acquisitions of healthcare systems involving inpatient mental health care, and say, I want you to just produce yes or no as an output. Is it or is it not an inpatient mental health facility that was purchased here? You can hope that it produces the yes or no, but this is a fundamental, simple classification task. So what to do about it is to throw the right solution at it, and that does not necessarily mean go back to traditional statistics. You can do things like attaching a classification head to a BERT model and doing a low-rank adaptation of it in order to train it up on the task that you're looking for it to do. So use the power of these things instead of going back to first principles and training a logistic regression on some features you're extracting. Embrace the power of the large language models to understand the context within which you're working, but then do a more traditional computer science-y statistical evaluation of the outputs of that at the end. And
So I could see that we have, go ahead.
So I like your answer, but I want to temper it with, so you talked about a classification model, yes, no, and in fact, yes, no works a lot of times fairly predictably, and I think Sandy supports that. The issues we've run into is when it's not a super simple classification model. Getting a date, for example. So one of the problems we've had is we want to find out what the staging date of, a person who has melanoma, when did it become stage 2, right? It has a lot of trouble with that. And it won't give you the right date. It's in the note even, but it doesn't give you the right date. So when you have this more kind of either thousands of different classifications, if you want to call it, or as you approach an analog scale and you want to get the right value, it becomes harder and harder to get the large language model. That's what we found just from empiric stuff.
Sandy, you look like you might want to say something. No, yes?
I mean, I did have a curiosity question. In that scenario, were you using RAG or were you using?
We were using RAG, yeah.
Yeah, do you think that the issue is the vector database hit, or do you think it's the large language model in terms of getting the right date?
It's a great question. I think that in many cases, we could see the RAG model failed, basically. It failed, and that you could see pieces of text like all over the place, and it would pull them out, and they didn't actually even make sense, and for some reason it thought it was important. But even when we did drill into the pieces of text that it did pull out that were correct, it seemed to not be able to make a great decision about which date in a number of different optional dates that it might even have. And what was really scary is it would make up dates, which weren't even in the text anywhere, right?
Why should it be any better than human beings? I remember when I was on rounds as an intern, at a medical student, 5 o'clock in the morning, because I was with the surgeons, damn them, and I was looking hungrily at the plate of food given to the patient, and they'd say, what was the potassium? There was a strong urge to make something up. If I couldn't remember, I know it's low, okay, but how low? 3.6. Anyway, I'd like to shift to something that I think that you hinted at, Nathan, and that I think there will be a lot of interest. Can you talk a little bit about what your experience has been in working with local models? Because right off the bat, they do have the virtue that they're not going to change underneath you. And yes, I'm sure that at some level, the top line models that we don't have access to outperform all these models. But in terms of adequate performance, satisfaction for the job done, and how hard it is to actually get those local models running. What's your experience been?
Several different dimensions there. I guess I would frame this conversation in terms of sort of 2 dimensions of quality of output of these tools. One is obviously recall, and the other dimension is sort of reasoning, right? So my experience has been that even some of the very small models you can run locally, think something like Microsoft's Phi, they're actually pretty good at reasoning over context that you feed it. So you give it a couple documents and say, summarize this for me. Take this email thread for my colleagues. I've been out of work for a week. Tell me what they're talking about. They're actually pretty good at doing that. Where the smaller models, which is basically, anything from I think small at sort of the 70 billion parameter llama. That's the first thing that probably doesn't have enough parameters to really remember everything it's read on the internet, right? You look at ChatGPT and you can seemingly ask it anything and it just knows it right off the bat. There's so many parameters in there, it's retained memory of everything that it's read. So these smaller models tend to stumble. The ones that you can run locally tend to stumble when you're asking it to recall information from obscure places, which I would say, based on Zach's comment from earlier, that something like 20%, maybe a little bit less, of all the information these models have been trained on has something to do with medicine. Maybe we trust them, with making medical decisions. Maybe we don't. I think it's maybe a topic for folks other than me to debate. But I do think that when it comes to simple sort of I shouldn't say simple. When it comes to evaluating the context of a prompt and some other data that the model's been given, the local models run really, really well. You know, there's a variety of different resources that it can take to run some of these things. So
Give me your favorite so far local model.
Okay, I'm gonna humble brag here for a second.
Yeah, go.
Last fall, I realized that I needed to get myself up to speed on what it actually takes to deploy some of these things.
Yeah,
We
and
have the privilege at the medical school of having a half pod of NVIDIA hardware, which if you don't know what that is, it's a whole bunch of their H100 cards and a bunch of servers that are all interconnected, but it's completely committed all the time to folks doing research. So I said, I can't kick somebody off the cluster who's doing legitimate research so I can play with a chat bot. So I went out and bought one of these Mac Studio machines, right? And the nice thing about the Apple hardware, the current ARM, is that it has a unified memory architecture. So you can, for a few $1,000s, go out and buy a little box that has 192 gigabytes of video RAM and never breaks a sweat running inference on some of these models. So to get that
like which
sort of-
models?
So Llama 70 billion in 16-bit precision will fit just barely into 192 gigs on
And is
that
it a
machine.
token a second or 10 tokens a second?
So it will emit tokens about at the rate which I read. So it's a few tokens a second or so. So
how much does a 192 gigabyte machine cost?
I don't remember. Honestly, it was probably about $5,000. But the new ones, you can get up to half a terabyte of RAM in them, which is amazing.
All right.
And to buy that in NVIDIA gear, you know, you'd be running a liquid cooling system in your basement.
Okay, that's news you can use. Now, Shawn, what about you? You must have used some local models.
Yeah, I use a lot of local models because they're kind of fun, basically. So the problem that I have with thinking a lot about this is trying to understand as a human, right? Where is my preferences, right? Because I'm really used to getting answers like you just gave about the patient's potassium, right?
Right.
And I accept it. I mean, I'm totally fine with that. But the problem is that from an engineering perspective, often doesn't count at all. So let me give you the I2B2 problem. So in I2B2, we're going through billions of facts when we're looking things up, right? So the idea would be, okay, we're going to replace the whole thing with a large language model and go through billions of facts with a large language model. And most people kind of think about that, well, that's absurd, because basically what a model does, right, is it reduces your entire input to one vector. And every single thing about what you just had to put in your input is in one vector. And it's amazing what it can do from that one vector to predict then what the next word is and so forth, right? But it's going to lack the precision that you find in very large engineering solutions. So if you need very, very precise values in very large engineering problems, it's not going to work. And we don't even apply it in things like that, right? So we don't even think about saying, oh, you know, we're going to give it 400 million notes and find all the patients who have, you know, the word diabetes in those, right? But that's what we do with normal old natural language processing, right? I mean, you've been doing that for years,
Yeah.
right? So I think we have to kind of, it's a weird mental thing, which is that we tend to give it and accept solutions that that make it more like a human, and yet, you know, we forget that there's this whole class of engineering problems that.
Shawn, I'm going to push you in the direction that I was trying to push you.
Yes, okay.
Because I think it can help the audience. So either answer is going to be helpful. Either tell us how you were able to convince MGB to let you run a externally hosted LLM like GPT-4 on the cloud, Azure, or tell us that you were unable to do that. And if you're unable to do that, what local model do you? I'm just going to tell you, I have talked to dozens of people in the I2B2 community who have spent a year getting approval for access to an external. So what
I
have you
see.
done?
Oh, well, I think Sandy and I were just lucky, maybe. So MGB, being a big hospital and having this big relationship with Microsoft and so forth, had one of the early HIPAA compliant, so to speak, cloud-based models in
And
GPT-4.
And the IRB did not push back on you.
Well, I mean, a lot of
Care and feeding?
processing was needed to get, that kind of, but I think that at the end of the day, we had, some pretty big companies and so forth assuring us that, it could be.
Well, that's very important to share with the audience because, again, just hearing.
Interrupt. There's a backpack that's been beeping. Does this belong to anybody before I call security?
That was non-deterministic. One of the nice things about I2B2, for example, Shawn was able to get early on agreement to have multiple people access data through the I2B2 interface and getting the IRBs to agree to that back in early 2000s. Merely knowing that could happen allowed other people to go to their IRBs and get it approved. And so the fact that you're able to say that, Shawn, is actually helpful to other people to know that that MGB is doing it, the IRB has agreed, so there's some sort of government's risk calculation that they've made.
But I've talked to lots of people, even in this room, and they haven't been able to get that, done. So I think that's one of the reasons why, one, all of our examples are using local models because obviously they're on your machine and they're safe from the point of view of things aren't going away from your machine. Not that you can share weights and so forth if you train them. But the second thing is there's a whole class of I2B2 problems that we can solve that don't rely on patient notes. They're all, it's very, how do you get I2B2 to work better with what it's got right now in terms of, a huge ontology, which, Michelle has been able to put together on all the different characteristics of your patients, a very understandable query tool that makes you able to find patients who, abide by all these characteristics and so forth. And then, put it in a place where you can analyze that data thoroughly in the package that comes off of, the smaller number of patients and the smaller amount of data that's now tractable for a good, easy kind of engineering solution. So I think that's why we kind of are really dividing, what I2B2 is able to do with large language models into what it can do without notes and what it can do with notes. Because obviously it can do a lot of stuff with patient notes, but those are, one, hard to come by. Just getting the institutions to agree, right, that you can put notes into I2B2 is really quite challenging, actually.
Yeah.
And then if you do, how do you keep them safe, right? And there's a number of different options, but they're not uncomplicated. That you either have to de-identify them, which is pretty tough, even with large language models that kind of can. You're really going to do 400 million notes on the large language model de-identification process? Probably not. Or you keep them encrypted and then in a safe space for computation, which kind of can work too. But again, the institution's got to approve all that. And then finally, we expose ourselves to all the issues that patients have lots of doctors put very nuanced things about patients in notes. And some of those things are not things that we would actually want to be used by a computational system to think about us.
Okay, before Nathan responds, I'm going to look at Diane. I think we have 15 minutes left. We have 5 minutes left? All right, so this is, whatever these guys want to talk about, more important is what questions. So here you have a group of really amazing individuals who have already had the death by 1,000 cuts. So if you have questions about using these models, come up to a microphone and ask now. Nathan.
Okay, and while you're walking, I just want to make the point that I have yet to see a retrieval augmented generation solution that has not gone as frustratingly as the one that Shawn alluded to before, where it's just a mystery as to what it's picking out of the vector database and how that information is being used. And this ties back into the question of running locally, because every time my team has sort of attempted this, we've just said we have no idea why it's doing what it's doing. I can't rely on it. So turning back to running locally, even these small models have enormous context length right now. Our solution has been, feed it the 70-page data dictionary, rather than having it try to go in, vector database, find the fields and the tables that you care about, feed the whole thing as context. And why do I say this relates back to the run locally question? Well, if you're going to feed it, 120,000 tokens through a for-fee API service, you're going to run up a pretty big bill pretty quickly, whereas you make a one-time capital investment in some of this hardware in your data center. Again, I get it, it's not free, right? The power, the cooling, the IT support, but it feels a little bit easier to justify some of those experiments where you're kind of replacing the non-deterministic vector database search with, I'm giving you the whole thing I expect you to work with right up front in the context.
Shawn.
So I think you have to remember that if you put in, a 70-page document, it's still condensing everything into one vector right before it goes and does its work to figure stuff out. So, you've got some compression thing that, 70 pages anyway. I do think that RAG technology is definitely in its infancy. I think the idea that, right now we do the chunking and we put these kind of blobs of text that lose their context often into and vectorize those and then search those for the semantic content is hurting us. What we have found is that if you make them much bigger, right? So if you take typically a RAG database will be composed of maybe 500 token chunks. If you make them 1,000 or 2,000, it actually does better because it keeps more context, even though it's compressing them more. So there's some kind of a way that balance of putting a lot of information in a vector reaches a limit at some point, but get to that limit so that you can preserve as much context as possible. I think that's probably the key to getting RAG to actually work.
If I could throw out a few thoughts. So regarding getting access to LLMs, the cloud-based LLMs within institutions, things that can be helpful to know is these LLMs can be made available to you, or some of the LLMs can be made available to you under a context where nothing is persisted. No prompts are persisted and no output is persisted. And in that context, it can be possible to get business associate agreements which bound the vendors to HIPAA. And then that's sort of the process that we went through to be able to get access to the large language models in that context. We did find, so in terms of RAG, like everything else, we found that it depends on the complexity of the problem that you're giving the large language model. In our world, like the performance that I showed at the beginning for the clinical trial use case, that was RAG. And we found that was within its capabilities. For the literature review use case, we have found RAG to not be within its capabilities. I'm particularly skeptical of RAG right now relative to anything that relies on genetics. But we have found that there are contexts where it performs well.
So I think this is probably going to be the time, although I see out of my corner of my eye that Shawn wanted to say something, but my duty is even stronger to Diane, who gave me 5 minutes 10 minutes ago. So I want to thank the panel, and on to the next part.